Hello friends, welcome back. Uh, this is another lecture on pre-stressed concrete. We will do another type of one problem. Uh, and before we go into the problem, let us again, it's just a summary of what we have discussed last class. These are the different types of losses that might happen in pre-stressed concrete. There are two types: immediate losses and time-dependent losses. Immediate losses are three types: elastic shortening, loss due to elastic shortening, loss due to friction and wobble effect, and loss due to anchorage slip or wedge slip in wedges. And the time-dependent slopes are loss due to creep, shrinkage, and relaxation stresses. And time-dependent slopes, it is happening for both pre-tensioning and post-tensioning, whereas elastic shortening, apparently it happens only for pre-tension, but in special cases it happens for post-tension. We already discussed friction and wobble effects only for post-tensioning, and anchorage slip also it's only for post-tensioning. Yeah, so these are the formula for finding out this thing which we have explained. Now we will be looking into another type of problem on elastic shortening, how to find out the loss in elastic shortening. Yeah, is that fine? So let us see. This is another problem. Let me read out the problem. A rectangular concrete beam 300 mm deep and 200 mm wide is pre-stressed by means of 15 5 mm dia wires located 65 mm from the bottom of the beam and 3 numbers of 5 mm wires located 25 mm from the top of the beam. If the wires are initially tensioned to a stress of 840 Newton per millimeter square, calculate the percentage loss of stress in steel immediately after the transfer, allowing for the loss of stress due to elastic deformation. So we need to find out the loss of stress due to elastic deformation here. Let us see what are the data given to you. So a rectangular beam of 300 mm deep and 200 mm wide. So breadth is 200 and depth is 300. Yeah, it is pre-stressed by means of 15 5 mm dia bars. So area of steel at bottom, it is 15 numbers, 15 into 5 mm dia, and at the top is 3 numbers of 5 mm dia. Yeah, location is given. It is top one is located at 25 mm from the top, and the bottom one, this 15 number of that 10 tens, they are located at 65 mm from the bottom of the beam. If the wires are initially tensioned to a stress of 840 Newton per millimeter square, so what is given is the F0. The initial stress in the 10 tens are given 840 megapascal. Calculate the pre-stress percentage of loss in the stress in steel immediately after transfer. So, and Young's modulus of steel and concrete, let us say it is given ES and EZ are given as 210 and 35. Let us say it is given. Okay, so from this we can find out let us say here we can find out the coefficient m, because we know that the loss is m into Fc. So we can find out m is nothing but the modular ratio, which is Young's modulus of steel divided by Young's modulus of concrete, which comes to be 6. Okay, and we need to find out Fc. So the thing is that here, since we have two steels here, one at top and another one at bottom, we need to find out the loss of stress in both. Means loss of stress due to shrinkage in top steel, and the same time loss of stress due to shrinkage, elastic shortening, not shrinkage, elastic shortening, and the bottom steel also. It has to be found out separately. Yeah. So another problem which is this catch here, it is we have a steel at bottom, we have a steel at top. So the thing is that the eccentricity, we need to find it out. The eccentricity is nothing but the center of gravity of the tendons, distance between the CG of the tendon and the neutral axis. This is the neutral axis. Let us say, because we have one at top, another at bottom, so we need to find out the center of gravity of these two tendons first. So once we got the CG of these two tendons, the distance between that CG and the neutral axis will give you the eccentricity E. Once we got E, we can find out the stresses FC at each level. Yeah. Let us see how to find out center of gravity. We have done a problem, if you remember, on I sections, wherein the tendons are distributed unevenly. Yeah, and so we have found out the CG like that. Yeah, we need to find it out. So before going to that, let us find out easily what are the other things possible. We can find out the initial force. The stress is given to you 840, so that the force in the steel we can find it out. Yeah, because we need it for finding out the stresses. Yeah, P0. So stress force is nothing but stress into area. So stress is 840 given to you, and area is area of the tendons. So pi d square by 4, 15 numbers into pi d square by 4 plus 3 numbers into pi d square by 4, which will come around 296 kilonewton. That is a force, pre-stressing force, initial pre-stressing force. So let us find out the area of steel also. So pi d square by 4, the top, 15 numbers plus 3 numbers at bottom, top, into pi d square. So 15 at bottom, 3 at top. So total together it will come around 3.53. Yeah. Right. This comes around 6.66. Yeah. EC is 31.5. Yeah, say 31.5. EC is 31.5. Okay, 1.5. There was an error. 31.5. Okay, it's okay, no problem. It's only a typographical error. So we got M is equal to 6.66. So where we are now? Let us find out the center of gravity of the tendons. How do you find out center of gravity of the tendons? Same way, y bar. Let us say the y bar is the distance from the bottom of the beam to the CG of the tendons. So y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. Y bar is nothing but y1 is the first tendon from the CG of the first tendon to the bottom, that is y1 65, it is given to you, and y2 is the CG of the second tendon and the bottom. So y2 is we can find it out. Total it is total is 300 minus 25 will be 275, and the total area 353. So it comes to the work calculated to be 100 mm. Is the y bar is 100 mm. So this is the eccentricity. You see, this is a neutral axis, and this red color line is the CG of the tendon, and this distance is the eccentricity. So this is 150 minus 100 will give you 50, the eccentricity E. Okay, so let us find out the stresses at the top, stress in the concrete at the top, in the top wire, at the level of concrete in the top wire and the bottom wire also. Okay, so let us say this YU upper distance is from neutral axis to this point. Say let us say YU, that you will find it out as 125, and from the neutral axis to the bottom, that is find it out as Y lower is 85. So we know, because we have discussed previously, this P, the stress in the concrete. So it is P by A minus, because of eccentricity there will be a minus will come, because eccentricity is below it is. So it is top will be tension and bottom will be a compression. So P by A minus PE. P by A minus PE, because it is P is M by I by Y, right? That is M by Z, that is I by Y. So this Y will go up. So PE into Y upper, because we are talking about the upper steel, divided by I. So Y upper you already found it out, 125. So PE is you've already found out. P is 296 into E is 50, right? Y upper divided by I is PDQ by 12. Yeah, so you will get 0.83, at the level of bottom wire, it is P by A plus, because why plus? Because it bends down, bends up, the eccentricity is bottom, so bottom will be bottom layer, it will be compression. So plus PEY lower divided by I, which is equal to 7.85. So this is the less. So once you got the stress, whatever you found out is the FC, then loss of stress in the top fiber is M into FC. M is your you found out already, M is 6.66, so it will come around 5.55. Loss of stress in the bottom fiber, it is 6.66 into FC. FC here it is 7.85. Okay, so percentage loss in the top, because actual stress on the top is actual stress on the wire is 840. So percentage is 5.55 into 100 divided by 840, 0.66 percentage. Percentage loss in the bottom, it is 52.5 into 100 divided by 840, so it will come around 6.25 percentage. Yeah, I think hope this is clear. The only thing here it is we need to find out the Y bar, and we need to find out the loss in stress separately for the upper wire and the lower wire. Yeah, so this is what, so BDPE by Z, M by Z, Z we cannot use here, because since we have different because we wanted to find out the stress at the level of steel. So PE into Y upper by I, and here PE into Y lower by I. So once you please go through it, it will be clear. Thank you very much.